students, this is Dr. John, your physics and math professor. We're doing another tension problem today, and this is about the little engine that could pull these three ore cars. So here we have the little engine moving this way, and we have three different ore cars with three different weights, 150 kilograms, 60 kilograms, and 100 kilograms. I sort of ran out of room there in my illustration. And the train is accelerating. The whole train together is accelerating at 7 meters per second. We're supposed to find these different tensions. Tension 1 between the engine and this, tension 2 or tension B, and tension C, ignoring all friction and stuff like that. So at first glance, this may seem like a complicated problem, but I'm going to break this down for you. We're going to do a little piece at a time, and I think it'll become pretty simple by the end. So here I've done a small sketch of this. Here's the engine, here's the tensions and the masses. So if we want to figure out what kind of tension is pulling this, let's just look at this third card here first of all. I'm going to put a little dashed box around it. So the thing that causes the ore car number 3 here, way down there, to accelerate is this tension C. That's the only thing that's going outside. Of course, we have a normal force going up, and we have a massive force of gravity going down, but we're ignoring those because we're ignoring friction, so we don't need these. These perfectly balance each other, and we don't need them. So the only other thing that's coming, the only other force coming outside of 3 is this force of tension C, tension C. So tension C here is actually equal to the force, because tension is another way of stating force. Force and tension are the same thing. So tension C here is the force that's pulling cart 3. But that has to also be equal to the mass times acceleration of cart 3. We know the mass, it's 100, and we know the acceleration, it's 7. So it's going to be 7 meters per second squared times 100. That one's very easy. That's 700 newtons. Tension C is equal to 700 newtons. Now let's look at tension B. I'm going to erase a few things. So if we want to look at this tension B here, the tension that's pulling cart 2, actually it's not just pulling cart 2, it's actually pulling cart 2 and 3. So if we wanted to put a dashed line around it, we would go like this. So the tension C is inside the thing that's being pulled. So it doesn't really matter. It doesn't matter what happens inside. It's only the forces that are going outside. Again, we have the normal force going up, the force of gravity going down, but again, those things aren't important. So the only force coming outside of 2 and 3 is tension B. So tension B is going to be the cause of the acceleration here. Well, we know what the acceleration is. The acceleration is given to us, where is it here? 7. The acceleration is 7 meters per second squared. And what's the mass? It's accelerating these two masses. So it's accelerating 100 plus 60, or 160 kilograms. I'm getting 1120, 1120. Of course, we could be looking at significant figures. Here we've got 2, here we've got 1, here we've got 1, and here we've got 1. It doesn't look like we're really concerned that much about significant figures, so I'm just going to leave it like this for now. We're going to say this is not a significant figure problem. So that's 1120 newtons. So for the tension in A here, which is the tension that's pulling all 3 of these train cars, remember B and C are internal. We don't worry about them. We don't worry about the normal force or the force of friction. So this is the only thing that's sort of going outside of our dotted line, which means tension A has to equal the acceleration, which we have here, 7, times all of this mass, because that's the mass that it's pulling. So we're going to have to add all of these up. This plus this is 250, plus this is 310. Let's multiply that out and see what we get. I'm getting 2170. So as we said, we're not as concerned about significant figures, so let's just write that down here. TC 2170 newtons. Put a comma in there for clarity. Put one in there as well. So if you notice, this one here is the highest, this one's the next highest, this one's the lowest. Always ask yourself if the answers are reasonable. They look reasonable, they look in the right range as well, and don't seem to be ridiculous answers. Ask yourself those questions. It'll help you to avoid silly mistakes. I hope that helped. If it did, like and subscribe, and I'll see you in the next video. Bye-bye.